Just check, screen is visible.
Yes, sir.
Yes, sir.
Okay, very good. If screen is visible, then let us start with what we had in last lecture. Let me have a quick look of it that. Come on. That was not the thing. Okay, we are done with this. Now, guys, look at here. That was the last point we have discussed yesterday. Effect of cascading on tuned amplifier. So we started with the analysis, and finally we have concluded that if the number of stages for an amplifier, for a tuned amplifier particularly, increases, then bandwidth decreases. For example, for single stage tuned amplifier you will get more bandwidth, but if you increase the number of stages, as you go on increasing the number of stages, that is for multi-stage tuned amplifier, what you will get a very much decrement in the bandwidth. It means if you are getting that kind of curve for single stage, then may you will get this curve for double stage. Right? For three stage you will get that curve. So as you go on increasing number of stages, the curve will become sharper. Right? The sharp curve you will get when you cascade this tuned amplifier. That's what the conclusion is. Now after this is a circuit diagram that I'm showing just to tell you that it's not only capacitor that can be used as a coupling element. We have inductor as well as we have transformer. So this is a single tuned inductively coupled amplifier. So inductively coupled means what? Obviously this tank circuit will remain as it is at the collector, but the output of that tank circuit is coupled via an inductor. So that's why it is called inductively coupled. If you connect a coil or an inductor, your single tuned amplifier will become your inductively coupled amplifier. See, we are not going to analyze this circuit because it is just a type of coupling. Whatever equations I will get will be same as that of transformer coupled and this capacitor coupled. So that's why analysis is not important. I just want to tell you that it's not only capacitor. As an option to coupling, I can use inductor as well as transformer also. Is it? So I just want to show you the diagram, and check out, diagram is same, only the output of the tank circuit is coupled via or through the inductor. Yes, and that's not the only thing. Now after that, let's move towards the double tuned amplifier. The second type, look at this, second type of your tuned amplifier circuit is double tuned amplifier. So far we have discussed single tuned amplifier, that is single frequency is tuned. Now here we have an option that I can select, I can tune more than one frequency, more than one frequency. For example, I can select 98.3 and 94.3 at the same time. This is what more than one frequency can be selected. It means my tuning amplifier or my tuning circuit is now giving two resonant frequencies. Is it? That can be the explanation if I go with the name itself, double tuned amplifier. Yes, so one can say double tuned amplifier means instead of having a single resonant frequency, now this circuit has to provide double resonant frequencies. Two resonant frequencies must be there. Is it? Now, whether to get two resonant frequencies or there is a different meaning for that double tuning, that we need to check. Is it? So, what is the thing that I can determine from the name itself? Double tuned amplifier. Yes, it has to tune for more than one frequency. I can select more than one frequency. That can be. But how this is achieved, or whether to achieve double tuning or to achieve two resonant frequencies, that's what the aim, or just a single tuned amplifier with some modifications is the name for that, or it is the another version simply. Is it? So instead of discussing those things, what we will do, We will start with some theory of coupling, and then you will come to know why I'm telling you that the name itself saying double tuned, so that I can get more than one resonant frequency or something like. Right. Now see why the basic aim is not to get two frequencies. The basic aim is different. Right. Otherwise, generally what happens, people read the title double tuned amplifier and they conclude that more than one resonant frequency is there. And that's what. But the motto or the basic purpose of a circuit is quite different. That's why I'm writing why to go for double tuned amplifier. Is it? It means now single tuned amplifier is there, but single tuned amplifier has very narrow bandwidth. Look at this. The bandwidth is very narrow, and that's why the reproduction of audio signal or the radio signal is very poor. Is it? Why very poor? Because of the narrow bandwidth. So it means if I increase the bandwidth, that can be the new circuit that I can call it as a double tuned amplifier. It is like that. Or just dealing with this parameter, bandwidth is the extra benefit that I'm getting in double tuned amplifier. So if it is, then that thing that getting higher bandwidth is not going with the name double tuned amplifier. I hope you get my point, because see, now I'm talking about increment in bandwidth, but the name is showing it is something like getting double resonant frequency. Is it? So there is a quite relation. If I start increasing bandwidth, I will get more than one resonant frequency, and that's why the name double tuned amplifier is there. Is it? So what I tried for, I didn't try for getting two resonant frequencies directly. I tried for increment in bandwidth. I started increment in bandwidth. I started increasing the bandwidth, but what I observed, if I am working on that bandwidth increment, I am getting two resonant frequencies. Look at this, the frequency graph will be like this. This I can call it as resonant frequency FR1, and maybe this I am getting FR2. Two resonant frequencies I am getting if I try to increase the bandwidth. So simply single tuned amplifier was there. I got that. I came to know that bandwidth is not sufficient. Now what to do? Let's try to increase the bandwidth. I started increasing the bandwidth. So what I observed, if I start increasing the bandwidth, I observe that now I'm getting more than one resonant frequency. So that amplifier I declared as a new type of an amplifier, and I call it as a double tuned amplifier. Double tuned amplifier. Now how things are there, let me tell you in next slide. Look at this single stage. Now that word is important, single stage, because sometimes that double tuned amplifier is configured with two stage also, but here intentionally I am writing title as single stage double tuned. See, single stage but double tuned. It means the same single stage tuned amplifier can give us two resonant frequencies. When it will give two resonant frequencies? When I try to increase its bandwidth. Is it? So how to go for increment in bandwidth? That is the question now. Is it? Okay, we'll enter into that. But before that, let us discuss. It is a single stage amplifier. Some people draw double tuned amplifier with two stages like this. Look at this. This is also a double stage amplifier, or this is also a double tuned amplifier, but it is two stage. Look at this. Here I am having stage 1, and from here it is stage 2. Is it? So it is two stage double tuned amplifier, and what I have now, I have single stage double tuned amplifier. Now in single stage double tuned amplifier, just observe the circuit. What I have this tank circuit and I have another tank circuit. So this another tank circuit is coupled to the first tank circuit. Is it? And whatever operation is there, I have written here. Look at this. Go through these lines, you will get almost everything. Now what's the point? The frequency or input signal. For example, if this is what input signal F1, my tank circuit, if I say this is what tank circuit 1 and this is just simple coil, then the tank circuit 1's resonant frequency FR, that resonant frequency, when it is matching with this FR signal, Then look at this, F1 and FR. When they match, the tuning circuit, here I have written clearly that tuning circuit L1C1 is tuned to the input signal frequency. Input signal frequency is F1. It means now I have to change this FR and make this FR equals to F1. Then only F1 can be transmitted forward. Or at this condition, the tuned circuit offers high reactance to the signal frequency. Consequently, large output appears at the output of a tuned circuit L1C1. It means at resonant frequency, what happens? This tank circuit gives maximum output voltage, or the amplifier gives maximum output voltage, and that maximum output voltage get applied or get transferred to the another tank circuit, is it? And from another tank circuit we can connect it to load as if you wish to, is it? And that's the simple operation. The simple and the easy operation as we have discussed in the last lecture maybe. Now what is the difference between this single and double stage? Look at this, it is two stage double tuned amplifier. Double tuned amplifier uses two inductively coupled tuned circuits. Two tuned circuits are there. Now look at this, this is stage 1 and this is stage 2. The operation will be same. Whatever output I am generating from stage 1 will be directly given to the stage 2, not directly, but it is coupled through this coil or tank circuit, and that's why I'm calling it as a two stage double tuned amplifier. Now see, here I didn't discuss about any bandwidth. I'm just telling you about the circuit diagram. What is there in the circuit diagram? In two stage tuned amplifier, two stages are there. In single stage double tuned amplifier, one stage is there. I didn't talk about where is double tuning. I didn't talk about where is the increment in bandwidth. Is it not? मी अजून बोललोच नाही ना त्याच्याबद्दल काही. So let us think about the basic purpose, is it? Whether or why I am getting that double tuning in a single amplifier, is it? So those are just methods. How can I configure a double tuned amplifier? You can configure it using single stage or go for two stages, is it? Now the basic concept starts here with the coupling, is it? The coupling, tight coupling and loose coupling. Now just go through this slide. It is all about coupling. We know what is coupling. Coupling means what? Look at this one, tank circuit is there. If I'm saying tank circuit 1, tank circuit 2, and those tank circuits are mutually coupled. Look at this, under the concept of mutual inductance coupling, I'm connecting tank circuit 1 to tank circuit 2. It means if the current is there, if the output voltage, if the energy is available with the tank circuit 1, all energy can be transferred to tank circuit 2 via mutual coupling, is it? Now look at this, when the coils are spaced apart, the flux linkages of primary coil L1, this is I'm talking about L1, will not link the secondary L2. It's an obvious. If you increase this distance, this I'm talking about, if you increase this distance, then linkage will be poor, is it? At the condition, the coils are said to be loose coupling, is it? अगर आप यहाँ का distance बढ़ाओगे, so obviously there will be a very poor linking between L1 and L2, and because of that we will call it as loose coupling. It is called loose coupling. Right. The resistance reflected from secondary coil at this condition is small, and the resonance curve will be sharp, and the circuit Q is very high. Is it? Now what is that Q? Q has inversely proportional to bandwidth, that is well known to us. Q is inversely proportional to bandwidth. Now look at here. What I'm doing, I'm just increasing the distance between L1 and L2. That. So if you increase the distance between L1 and L2, the poor linking will be there, the pure mutual inductance coupling will be there, and because of that I'm calling it as a loose coupling. What happens if I have loose coupling? The resistance reflected from secondary coil into the primary coil L1. You know that reflection of resistance. We have studied this reflection under the chapter power amplifier, I think. Yes, power amplifiers. When we start with power amplifier, we had a discussion about this RL and RL dash. So that RL dash right now I'm talking about, it is reflected resistance, is it? That reflected resistance is very small. Obviously the distance is very large. Loose coupling, reflected resistance will be very small, is it? And because of that, what happens, the resonance curve will be very sharp because the Q is very high. Look at this, the Q becomes very high and that bandwidth will be very small then. So that's why what I will get very sharp curve like this. Look at this, this is what curve I will get if I have this loose coupling, is it? Now second option is why to increase the distance between L1 and L2. Let them come closer. Look at the second slide. Now what I'm doing, I'm decreasing the distance between L1 and L2 and now I'm calling it as a tight coupling. Look at this, this is what I'm giving a separate name for that, tight coupling. On the contrary, when the primary and the secondary coils are brought close together, it means I'm talking about the distance D between coil L1 and L2. Now the D is very small, I'm keeping those L1 and L2 very close to each other. In that case, I'm referring it as a tight coupling. So what happens when I tight couple two coils? The reflected resistance will be large and Q will become very small. So if that Q is very small, then obviously bandwidth will be very large because we know the relation between Q and bandwidth. Now, in that case, as you go on increasing the distance between two coils, you will observe that we are getting two resonant frequencies. We are getting two resonant frequencies. So when I'm getting this at tight coupling, look at this, two positions of gain maxima, one above and other below the resonant frequency. That's what you will observe, that if this is what your resonant frequency, the desired frequency or the frequency of your tank circuit that you have connected, apart from your resonant frequencies, somewhere at higher frequencies I'm getting maximum gain, and somewhere at the lower frequencies also I'm getting maximum gain, is it? That's what when I tight couple two inductive coils. So in tight coupling, one can observe that instead of exact at resonant frequency, some frequency which is higher than resonant frequency I'm getting maximum gain, and some frequencies which are lower than that resonant frequency, there also I'm getting maximum gain. Look at this, if I say this is what gain maxima. So two maximas are there if I tight couple that, and because of that two maxima, it is referred as double tuned amplifier. So understood what do you mean by double tuned amplifier? Just increase the distance, just decrease the distance. Yes, it is all about that. Tight coupling means what? Decrease the distance. If you decrease the distance between L1 and L2, it will be your tight coupling, and when tight coupling is there, you can observe two maximas at two positions. You will observe the maximum gain, is it? Now just check it out. These two maximas, I am referring it as two peaks. Look at this. Now apart from this resonant frequency, apart from this frequency, somewhere here, somewhere at this point, I'm getting one resonant frequency. I will call it as FR2, and somewhere here I will get FR1. Agreed. So what is this called? This is from resonant frequency to this minus 3 dB line. So obviously whenever I'm getting lower dip, For example, see this at resonant frequency is sometime I'm getting lower dip, is it? At that lower dip I will call it as gain at dip, and this is what gain at peak. So gain at peak, those frequency I'm referring it as an F1, F2 or FR1 and FR2, and at the dip I will have that bandwidth kind of thing, is it? Look at this. And the previous diagram is this curve. This curve was, it is for loose coupling. So in that case, if I want to show it here, then here I will get a dip and this is what a peak, is it? And even if you take this as a bandwidth, then also you can say the bandwidth is increased. Agreed. And look at this we referred it as a del, that is a difference between frequencies, or what I can say deviation in the frequencies. So this is about the two stage double tuned amplifier, or we can say a simply single stage double tuned amplifier. It doesn't matter whether you are going with single stage or double stage. The thing is, if you are try to increase the bandwidth, you will get two peak signals, you will get two resonant, you will get two tuning. That's why the circuit is called double tuned amplifier, is it? Now bandwidth of the double tuned amplifier circuit, look at this, the figure that we have shown previously, this and this, it states that the bandwidth increases with degree of coupling. If there is a close coupling, bandwidth increases. And the determining factor in a double tuned circuit is not Q, but it is a coupling. Because see, when you tight couple, the bandwidth increases. Now every time it is not necessary to calculate the Q factor and check whether Q is high or low and then conclude with the bandwidth. No, even if you tight couple it, you will get increment in the bandwidth. We understood that for a given frequency, the tighter coupling gives greater bandwidth. Now, and that's why, look at this bandwidth equation I can write like this, where BWDT, this part is what bandwidth for double tuned amplifier circuit, which is equals to K means what, coefficient of coupling. Obviously if I'm using tight or loose coupling, that K must be in the picture. And what is that FR? This is a resonant frequencies. So bandwidth is what, resonant frequency multiplied by just coefficient of coupling, is it? Some people write it as KFC. That FC is nothing but your resonant frequency or center frequency. It has the same meaning of that. You use the notation FR or FC, no issue, is it? It's just a resonant frequency multiplied by that factor. What's that factor? It is coefficient of coupling, because the bandwidth is totally dependent on the coupling. Every time it's not necessary to go with Q only. We know that Q is inversely proportional to bandwidth, but it's not necessary to go with Q all the time. Right? Even if you know the coupling coefficient, then also you can calculate the bandwidth if you know the resonant frequency. That's all. Now, what are the advantages? The advantages is flat response. Obviously bandwidth is more, it means obviously response is very flat or flattered response, is it? Large 3 dB bandwidth, just an obvious. Larger gain bandwidth product, that is gain multiplied by bandwidth, that product will be large. Why? Because bandwidth is large, is it? Any one is large, obviously you will get this product very large. Here in my case bandwidth is very large, and that's why this gain multiplied by bandwidth product is very large. What is that gain bandwidth product in case of BJT? This is what FT. What is that? It is a last column in your data sheet. I hope you remember that from your first semester. Now, what is the effect of cascading double tuned amplifier on bandwidth? Is it? Just go with this. The effect is same as that of single tuned amplifier. Now look at, when identical double tuned amplifier stages are connected in cascade, the overall bandwidth of the system becomes narrow, is it? And that's why it is always good to have a double tuned amplifier with single stage or single stage double tuned amplifier. If you go with double stage or two stage double tuned amplifier, you will get a narrow bandwidth, not a desired one. For example, if you are expecting 1 megahertz, then obviously after connection what you will observe, you will observe less than 1 megahertz. Is it? Why? Because of number of stages. As you go on increasing number of stages, bandwidth will decrease. So it is always good option to increase the bandwidth for double tuned amplifier is to go with single stage double tuned amplifier, is it? And that's the conclusion is same as that we had in single stage or single tuned amplifier, is it? When single tune stages are cascaded, yes, it is done. Now those are the effects, and we are not going to analyze the effect in case of single tune amplifier. See what we had a mathematical analysis how bandwidth get decreases if I increase the number of stages. Look at this is what the analysis we had, is it? And the same analysis, the same concepts are applicable for this double tuned amplifier, is it? So there is no need to analyze double tuned amplifier with the same method, is it? There is no need because already we had an analysis. The same analysis you can copy and paste here for double tuned amplifier. Only thing is here you have two options, either go for single stage double tuned or two stage double tuned amplifier, is it? Now the third type is stagger tuned amplifier. Probably we'll start this stagger tuned amplifier as it is a last point from your syllabus, I think. Yes, it is the last point. Then we can continue this in next lecture because already we started our lecture very late because of that network connection.